Hello everyone, welcome to PUC Physics Explained channel. In this session, I'm going to take PUC First Year Physics Chapter 1 Units and Measurements. In that, the second session part is 1.3 Significant Figures. The significant figures are required for the precision of measurement to have the less errors. And that's why if you consider any measured value, it have the number and a unit, and the number what it is there, it may be a whole number, that is a non-decimal number, or it may be a decimal number. If those numbers are there, those numbers have the number of digits, and how many digits are reliable and certain, and those number of digits are to be considered as important, and those digits are called as a significant digits or a significant figures. And concerned to this significant figures, the detailed the material reading material I am going to give in this PPT, and also I will explain the details of it. Kindly subscribe to PC Physics Explain channel. If you are already subscribed, kindly share and comment. And here details we are going to take there during the measurement, the what the number or value we have, and to have the precision of that measurement, to have the less error, how the significant figures are to be considered by taking the five significant figure rules, and also some of the observations we are going to take. Here all notes every measurement involves errors. The measurement involves errors because number of digits what will have the some rounding, some the only the few digits are to be taken in that one. That's why the all measurements will involve the errors. Thus, the result of measurements should be reported in a way that indicates the precision of measurement. Should have the precision of measurement. In that way, we should be indicated the measurement or a value which is measured. Normally, the reported result of the measurement is a number that includes all digits in the number. What number is that? It will be having all the digits in the number that are known as reliable numbers plus first digit that is uncertain. That is a reliable no, digit what it is there, and also the first digit that is uncertain. Those are to be taken in the number what is to be measured. Okay, that is the measured number or a measured value. And here the reliable digits what are taken after the measurements plus of the first uncertain digit are known as significant digits or significant figures. Okay, in the measured number or a value what we are going to have, that will have the reliable digits plus of the first uncertain digit, and all these are included what it is called, that is a significant digits it is called, and significant number we are going to call. Here if you take the one example, if you say the period of oscillation of a simple pendulum is 1.62 second, the period of oscillation, the digit 1 and 6 are reliable and certain. This 1 and 6 are reliable and certain digits, while the digit 2 is uncertain. While the digit 2 is the uncertain, that means it may be 1.619 like that it will be there. That is, it may be rounded up, or it may be having some other values behind this one, and that's why it is a uncertain, that we are going to call as a uncertain. It may not be certain or a reliable, and these together, thus the measured value has three significant figures, that is the certain or a reliable digits and the first uncertain digit. All together we are going to take as a significant figures. That's why in this one, this first one is a reliable and certain, second is also reliable and certain, the third one is the first digit of the uncertain in the measured value. That all three are significant figures. And another example we'll take here, the length of an object reported after measurement to be 287.5 centimeter. And here these three digits 2, 8, 7 are reliable and certain digits. And point after the decimal point 5, what it is there, it is the first uncertain digits. And all together we are going to take as a significant figures, so that it will have the 4, 1, 2, 3, 4, four significant figures. The digits 287 are certain while digit 5 is uncertain. Okay, this is an example how the significant figures are taken, and based on this one the observations are set. Here clearly reporting the result of measurement that includes more digits than the significant digits is surplus and also misleading, since it would give the wrong idea about the precision of the measurement. If the measure value what it is there, it will have the more than the significant digits, more than the significant digits, and those are called as surplus. And that measurement leads misleading, since it will give the wrong idea about the precision of the measurement. Now, one example we'll take here. This pi value is 3.1415926 and so on. Continuation. The up to infinite, the digits are there in this one. And the certain digit is this one, reliable, and this is also certain and reliable. The two we are going to take, and the first digit of the uncertain, this we can take in the is significant digits, significant figures, and these are we are not going to consider in the significant digits or significant figures, and that's why this number we can write like this. This is the 3.14. This 1 can be rounded up to the 2, and how that is rounded up, the later rounding the of these numbers in the arithmetic operations I'm going to take later. And this can be written as 3.142 or 3.14 only, the three uh, significant figures. Okay, like this, if you not take like this, the value what we'll have, that may use the wrong idea of the about the precision of the measurement, and that will lead the mislead the what it will be measurement is there, and these values are called as a surplus digits. This is an example. And thus the rules for determining the number of significant figures can be understood from the following example. Here the rules are set. There are 5 rules are there. Those are set for the considering the significant figures. Because here what number of digits are to be considered, what are not to be considered, and how many the significant figures are taken from the particular number. For that there are the number of rules are there. The totally 5 rules are there. Based on that we are going to take the significant figures, and these rules are set, and based on the one example what we'll take here, the significant figures indicate, as already mentioned, the precision of measurement. Already what we mentioned, it indicates the precision of measurement, which depends on the least count of the measuring instrument. The measuring instrument what we'll take, it may be weighing machine, or it may be length measuring instrument, or it may be any other thing, temperature measuring instrument, like that. That whatever the precision of measurement, that will be depend on the least count of the measuring instrument, and there based on that one the precision of measurement depend, and based on that the significant figures we are going to consider. The common rule is that the common thing what is to be considered for taking the significant figures, a choice of change of different units, the choice of change of different units does not change the number of significant digits, or significant figures in measurement. Here, if you take the any value with the different units, for example, a length may be taken in terms of the meter, centimeter, millimeter, kilometer, and mass may be taken in terms of the milligram, gram, and the kg, like that. The choice of that unit does not change the significant numbers, significant digits, or significant figures in the measurement. That is the common method of the consideration of the significant figures. Further moving, the important remark making most of the observations clear. In that, the some observations we are going to take. In that, the first observation is that, for example, the length 2.308 centimeter has four significant figures. Here, the this 2.308, this one value having the four significant figures. This is 2, 1, 3, second one, 0, third one, fourth one, 8. It has the four significant figures. Further moving in this one, but in different units if you take, the same value can be written as 0.02308 meter or 23.08 millimeter or 23080 micrometer. All these numbers should have the same number of significant figures. That is digit 2, digit 3, digit 0, digit 8. All these have the four significant figures. Four significant figures. That means here this is the observation is that these are the four significant figures, this is the four significant figures, and here these are the four significant figures. The zero is not taken, and for that there are rules that we are going to take further. This shows the location of the decimal point is of no consequence in determining the number of significant figures. Here the decimal point position. Here, after the first 0, there is a decimal point. Again, 0 is there. This 2308 written. And after the 23, the decimal point is there. And in this one, there is no decimal point. And this decimal point does not have any consequence in determining the number of significant figures. Further moving, the example what it is given that gives the following rules. From this, the some of the rules we are going to take for this. The first one, all the non-zero digits are significant. Non-zero digits. Here, 2, 3, 8 are significant as per the first rule. That is in this one example, 21, 2 and 1 non-zero, 2 significant figures. 5, 1, 3, all 3 are non-zero and 3 significant figures. And here 1, 3, 4, 2, 5, all 5 digits are uh, non-zero and all are significant figures. Then moving to the second rule, all the zeros between two non-zero digits are significant, no matter where the decimal point is, if at all. Here, the zeros between the two non-zero digits are significant, no matter where the decimal point is, even though it is a decimal point, but between the two non-zero digits, if the zero is there, that is also a significant. Here we can take there is a 1 or 2 as a number having the 3 digits, and 1 is a non-zero, 2 is non-zero, and between these two there is a 0 that is also become a significant. Therefore, there are 3 significant figures. Second example, 1001, and here 1 is significant as a non-zero number, and last one is also a significant, it is a non-zero number, and there are two zeros between these two non-zero numbers. Those are also considered as a significant figures. Therefore, it is a four significant figures. And third example, 1201, and 1 is significant and 2 is significant and 1 again significant, and 0 is there between the 2 and 1 non-zero digits, then 0 is also a significant. There are 4 significant figures. And here the decimal point examples will take the 2.308. Then here the 2 is significant, 3 is significant, 8 is significant. And 0 here after the decimal point, even though it is, okay, that is also a significant. And that's why the 4 significant figures. And next example is 208.09. There is a here 0 is between 2 and 8 digits, non-zero digits. It is also a significant. And here 0 is between 8 and 9, two significant digits, and therefore that 0 is also becomes a significant, and the totally 5 significant figures in this one according to the second rule. And moving further, third rule is that if the number is less than 1, there is a decimal number, the zeros on the left of the decimal point, zeros on the left of the decimal point and up to the right of the first non-zero digit, right of the first non-zero digit are not significant, are not significant. The example here will take here the value is that 0.002308. What the example previously we have taken. In this one, 0 is the 0 of left of the decimal point. That is not significant. And here up to the first non-zero digit, what the zeros are there in the decimal numbers, those are also not significant. Therefore, all these three underlined, these are not significant. Therefore, it will have these four numbers only the significant according to this third rule of the significant figures. The underlined zeros are not significant. Then fourth one, the terminal or trailing zeros in non-decimal number are not significant. Here example, if you take the thus 123 meter, this can be written as the 12300 centimeter or 123,000 millimeter. Okay, here according to the fourth rule, this trailing zeros in the non-decimal number. This is the non-decimal number. It is not having any decimal point here. And that's why in the non-decimal number, trailing zeros are not significant. Therefore, these three numbers only significant is according to the this fourth law, and the same is observed from the first rule. There the that first observation where we got that is even the choice of the unit does not change the number of significant figures. In the first one 123 meter, the first all three are significant. Here also it should be three only, and here also three significant figures only. Therefore, as three significant figures, the trailing zeros are being not significant from the first observation. And fourth rule is says that one trailing zeros in the non-decimal number are not significant. Fifth rule, trailing zeros in a decimal number are significant. Trailing zeros in decimal number are significant. The number is that 3.500, and here in the decimal number this may not be 0, the 5 may not be it is a certain value, and that's why these values what are there, those are uncertain, and that's why here that may be having the different values, and that should be taken into a significant numbers, and that's why here the significant digits 3, 5 are non-zero, and the trailing zeros what are there in this one are significant. Therefore, these four are the significant. And according to that second rule that what we have taken, that is a 0 before the left of the decimal point and 0 of the right up to the first non-zero digit are not significant. According to that, these two are not significant, and therefore The 6, 9, these are the non-zero numbers, therefore those are significant, and trailing zeros in the decimal numbers are significant, therefore these having the four significant figures, have four significant figures each. Then we'll move further. The second observations, these five rules are over, and therefore some observations we are going to take from this one. The observations are, there can be some confusion regarding the trailing zeros. There may be some confusion. Okay, the trailing zeros concerned to that. Okay, the one example take, and how the confusion it will be there, and how that confusion can be eliminated or removed. Suppose a length is reported to be 4.700 meter. It is evident that the zeros here are meant to be convey the precision of measurement and are therefore significant. As we know that according to fifth rule, the zeros also significant, and those are conveying the precision of measurement, therefore those are also significant. Then if these were not, these are not significant, what we can say, it would be surplus. If these are not significant, then those two would be surplus. To write them explicitly, how we can write them? The reported measurement would have been simply 4.7. If it is a reported result, if it is 4.7 meter only, then now that discussion, if you continue, now suppose we can change units, then 4.700 meter equal to 470.0 centimeter, that is equal to 4700 millimeter, or that is equal to 0.004700 kilometer. In this one, since the last number has trailing zeros, in a number with no decimal, here the it is having the trailing zeros with no decimal, we should conclude erroneously from observation 1. From observation 1, we can say above that the number has two significant figures. If you mention from this, it should have the two significant figures only. Okay, because the trailing zeros are not significant according to the observation 1. But while in fact it has four significant figures. It has the four significant figures. And mere change of units cannot change the number of significant figures. Okay, here the merely simply we are changing the units. It should not lead to the any change in the significant figures, and that's why, okay, here by taking this one only, we cannot say it has the only the two significant figures, but it should have the four significant figures. Then how this can be eliminated? There is a little confusion, but how can be eliminated, that we can discuss here. In this one, third observation, what we can take for the eliminating that. To remove such ambiguities in determining the number of significant figures, the best way is to report every measurement in scientific notation, that is in power of 10. In such ambiguities, if you have, then that number may be written as a scientific notation. And there is a in power of 10 we can write. How the power of 10 we can write? We can, here we'll take the theoretical discussion first, and later we'll take the examples. In this notation, every number is expressed as a into 10 raised to b, where a is the number between 1 to 10 and b is any positive or a negative exponent. Okay, here the a should be 1 to 10 and b is any positive or negative exponent of power of 10. Okay, the b is power of 10. In order to get an approximate idea of the number, we may round up the number a to 1 for a is less than 1 and to 10 for a is between 5 to 10. Okay, that approximation idea we can take. Then the number can be expressed approximately as 10 raised to b, in which the exponent or a power b of 10 is called the order of magnitude. That whatever the b what considering the which is power of 10, there is a order of magnitude of physical quantity. There is a order of magnitude of a physical quantity, that is B. When only an estimate is required, the quantity is of the order 10 raised to B. Only estimate if it is required, the order of 10 raised to B we can take. Then example we can take here. The diameter of the earth is 1.28 into 10 raised to 7 meter, is the order of 10 raised to 7 with the order of magnitude 7. The diameter of the hydrogen atom is 1.06 into 10 raised to minus 10 meter, is the of the order of 10 raised to minus 10 meter with the order of magnitude minus 10. Thus, the diameter of the earth is 17 orders of the magnitude larger than hydrogen atom. How the order of the magnitude we can take, that we can get from this. Then further, it is often customary to write the decimal after the first digit. After the first digit, any decimal values are there, that is customary to write. How we can write it? Now the confusion mentioned in A, that in the previous slide what the example we have taken, in that A above disappears. That will be disappears when taking 4.700 meter, that is a 4.700 into 10 raised to 2 centimeter, the 4.700 into 10 raised to 3 millimeter. Here we have taken 4.700 only in the previous case, but here we can write that is a 4.700 into 10 raised to 3. Therefore, that we can eliminate the what the confusion is there. Then 4.700 into 10 raised to minus 3 kilometer. Thus, in all this 4.700 meter, 4.700 into 10 raised to 2 centimeter, 4.700 into 10 raised to 3 millimeter, 4.700 10 raised to minus 3 kilometer. The power of 10 is irrelevant here. Whatever the power is there, it is irrelevant. That we are not going to take in the significant figures to determine the determination of significant figures. However, all zeros appearing in the base number in the scientific notation are significant. Here the all the zeros appear in the base number. The base number A what we have considered 4.700. All the zeros in that base number are appearing are also a significant in the scientific notation if you write that number. Therefore, here the each number in this case has the 4 significant figures. By expressing in terms of the scientific notations, any ambiguities about the trailing zeros we can eliminate. Further, thus in scientific notation, no confusion arises about the trailing zeros in the base number A. They are always significant. Then the fourth observation. The scientific notation is ideal for reporting measurements. That is ideal for reporting measurements. But if this is not adopted, we use the rules adopted in preceding example. Okay, if it is not adopted, then rules what it is there adopted in the preceding example, that's the 4.700 what we have taken, and there the merely changing the whatever the units are there, that does not change the number of significant units we can take. For a number greater than 1 without any decimal, the trailing zeros are not significant. Okay, if the number greater than 1, non-decimal numbers, okay, here trailing zeros are not significant. For example, 100 in that one significant figure, one only, the trailing zero in this one are not significant for the non-decimal number. For a number with a decimal point, trailing zeros are significant. With a decimal point, trailing zeros are significant. Therefore, here 1.00 if you take, the trailing zeros here are also significant. Therefore, 3 significant figures. Further moving, fifth observation. The digit 0 conventionally put on the left of the decimal for a number less than 1 like 0.1250 is never significant. Okay, this already we have taken in the second observation. After the Left of the decimal point, the 0 is not significant. However, zeros at the end of such number are significant in measurement. In the end, what are there? Zeros in the decimal number are significant. Those are also we have taken in the previous rule. Sixth observation is that multiplying or dividing factors which are neither rounded numbers nor numbers representing measured values are exact and have an infinite number of significant digits. For example, in radius r equal to d by 2, diameter by 2. Yes, surface area is equal to 2 pi r. The factor 2 is an exact number. The 2 is an exact number and it can be written as 2.0, 2.00 or 2.000 as required. As if it is required, we can write like anything. And similarly, in t equal to t by n, okay, that is t any value and n is also any value and t can be written as the ratio of these two where n is exact number. In this one, n is exact number and these what are there, okay, the infinite what are there, those are the infinite number of significant digits are there. We can conveniently we can mention these and we can have the significant figures. These are the observation concerned to the multiplication and division factors. And further, the arithmetic operations. In this one, arithmetic operations, additions, subtraction, multiplication, and division. There, how the this significants are to be taken, significant figures are to be taken. That I am going to discuss in the next session of this significant figures.